So sometimes we're going to have an equation that involves a square root. So we know that we can't manipulate outside of a square root very much. And so our safest bet is just to get rid of our square roots. So the strategy we're going to use is to isolate the square roots so that they're the only expression on their side of the equal sign. And then, because we know we have equality of our square root with something, when we square both sides, we still have equality. This will get rid of our square roots, and we'll be able to solve like normal. Okay, so we're going to start out with this example. So I know that 5 is equal to the square root of 4x minus 3. You can see that I've already isolated my radical. It's already in the form where it's the only thing on one side of the equal sign. Next, we're going to square both sides of the equation. So we know that 5 is equal to the square root of 4x minus 3. So 5 squared is equal to the square root of 4x minus 3 squared. This gives me that 25 is equal to 4x minus 3. And now I have an expression where it's really easy for me to solve for x. So I get that 28 is equal to 4x. So x is equal to 7. And because we were squaring, we're just going to double check to make sure that this is indeed a solution to our original equation. So I'm going to take the square root of 4 times 7 minus 3. This is the square root of 28 minus 3, or the square root of 25. And I get 5, just like I wanted. So x equals 7 is a solution. In the next examples, we'll see some cases where we need to be a little bit more careful, where we will have to eliminate sort of fake solutions that come out of as a result of the squaring. Stay tuned. In this next example, we have a little bit more work to do. So we know that x minus the square root of x minus 1 is equal to 3. We're going to start off by isolating the radical. What that means is we're going to move the square root to the right-hand side where it will be the only term there. So I'm going to subtract 3 from both sides. I get x minus 3 is equal to the square root of x minus 1. Next, I'm going to square both sides of my expression to get rid of my radical sign. This gives me x minus 3 squared is equal to the square root of x minus 1, all squared. So I end up with x minus 1. So x minus 3 squared is equal to x minus 1. Now, if I want to solve this quadratic, what I want to do is multiply out my left-hand side and consolidate. I have x squared minus 6x plus 9 equals x minus 1. Next, I'm going to consolidate. So this gives me x squared minus 6x plus 9 minus x plus 1 equals 0. And when I consolidate, I have x squared minus 7x plus 10 is equal to 0. Okay, this expression is pretty straightforward to factor. If we look at the factors of 10, we have 2 and 7, or negative, 2 and 5, sorry, or negative 2 and negative 5. So we're going to use x minus 2 times x minus 5. You can double check this by multiplying out. So it appears that there are two solutions, x equals 2, coming from x minus 2 being equal to 0, and x equals 5. So potential solutions. Okay, so we're going to check by plugging them back into the original equation. Because we did things like squared both sides to produce this equation, we have the possibility that we've introduced new solutions that are not solutions to our original equation. So I'm going to plug in and we'll see what happens. So I have 2 minus the square root of 2 minus 1. And the claim is that this is equal to 3. Okay. So this is 2 minus the square root of 1, or 1. It's not equal to 3. So this is an extra solution called an extraneous solution. That means it's a solution after we square, but not to the original. Let's check out x equals 5. We have 5 minus the square root of 5 minus 1, or 5 minus the square root of 4. So that's 5 minus 2, and this is equal to 3. So we actually only have a single solution of x equals 5 to this expression. We'll try another.